Hi folks, we're going to continue with our guided notes here for Algebra 2 for 7.2, and we're going to be solving exponential equations. And actually we are not going to do inequalities. That is one thing I cut out of this unit. And then we're going to be doing compound interest as well. So that is 7.2 today. So an exponential equation, as we spoke about in 7.1, is an equation where a variable occurs in the exponent. So as we saw 2 to the x, we saw 1/2 to the x. So our goal here when we solve these equations is to have the same base number, and then we're going to rewrite the new exponent. So in very simple examples, in our first example here, we want to rewrite these with the same base. And what a base number is this is the base right here, and this is the exponent. So we have a base and an exponent. So for here, well, 81 and 9, what do they have in common with a base number? Well, 9. 81 can also be rewritten as 9 to the second power. And then 9 can be rewritten as 9 to the first power. Well, let's try the same thing with 1/5. So if we have 1/5 as a fraction, this is the same as 1 over 5 to the first, which is the same as 5 to the negative first. 5 to the first can then be rewritten as 5 to the first. So here we go, is just rewriting our numbers right here, base and exponent. This leads us now into a little bit more complicated, but equally as, straightforward to solve as these were. So our property that we are given, property of equality for exponential functions, we're going to say our b value has to be greater than 0 and b cannot be equal to 1. So then if we are given b to the x power equals b to the y power, we can say this is true if and only if x equals y. So again, if we're given that two quantities are equal and they both have exponents, that means the two exponents must be equal. For example, if we have 5 to the x equals 5 to the fourth, then x has to equal 4. This is going to be the basis for us solving these next 4 problems. And I do have 4 problems for us to look at here because I do think it's going to be important for us to look at them. So here, we need to change the base. We have 3 to the x power, and this is going to equal 27. We have to make this base the same as 3, or just the same in general. So in this case, we have 3 to the x equals, well, 27 is 3 to the third power. Now I'm putting this in parentheses, and that's going to be important because 3 to the third power is now being raised to the 2x minus 4. What you have to do now before you can get rid of these 3's, the bases, you have to actually have 3 to the x equals 3 to the third times 2x minus 4 power. This is important because you have to distribute the 3 to the 2x minus 4 before you can solve for this. That way, now that we have the same base, we can say x is equal to 3 times 2x minus 4. So again, if we're saying that these two quantities are equal, the exponents have to be the same. We're going to use distributive property right here, and x is going to be equal to 6x minus 12. And solving from here then, we can actually add 12 to both sides. We add 12 to both sides. And I'm going to actually subtract x from both sides. So 12 equals 5x. And then solving for our x value, and we get 12/5 equals x. All right, so let's move on then to another one. Our first base is already kind of given to us over here, 7. So we have 49 to the x plus 5 power equals 7 to the 8x minus 6 power. We need these to be the same base. That means our 49 is the same as 7 squared to the x plus 5 power equals 7 to the 8x minus 6 power. Again, I have this in parentheses. That matters. So I'm going to take out the parentheses now. 7 to the 2 times x plus 5 power equals 7 to the 8x minus 6 power. All right. Now that we have the same base, I can get rid of the base and set the exponents equal to each other. Using distributive property here, I have 2x plus 10 equals 8x minus 6. And I'm going to add 6 to both sides, subtract 2x from both sides. So I'm going to have 16 equals 6x. Dividing by 6 on both sides gets us 16/6. However, we do need to make sure that is in the lowest form possible. And so 16/6 reduces to 8/3. And that is our x value. All right, so let's move on over here to solve these little bit more complicated ones. So as you can tell, 25 and 125 could both be broken down into a little bit smaller bases. So let's look here. 25 and 125 have the base of 5 in common. 25 is 5 squared, and this is to the 2x minus 1. 125 is 5 to the 3rd, and this is to the 3x plus 4. So again, now I want to make sure that I have the exponents correct. So we have 5 to the 2 times 2x minus 1 equals 5 to the 3rd times 3x plus 4. Now that our bases are the same, we can set the exponents equal to each other. 2x minus 1 equals 3 times 3x plus 4. All right, distributive property both sides right here. So we have 4x minus 2 equals 9x plus 12. All right, we're going to be adding 2 to both sides. Actually, let's actually subtract 12 from that so we can have x on the one side. So we'll subtract 12 from both sides. We get a negative 14. And we're going to subtract 4x from both sides, and we get a 5x. And dividing by both sides by 5, we get our answer of negative 14/5 equals x. Chose a lot of ones with fractions here, and that is okay. All right, our last example on this one right here is we have a fraction on the right-hand side. So that means we need that we know we're going to have a negative exponent, because if we have a fraction, then we can make that bottom number into the same base as the number on the left here. So let's do that. We have 4 to the 3x power equals, and you can check in your calculator, but 256 is 4 to the 4th power. So again, this is 1 over 4 to the 4th, which means that is really 4 to the negative 4th power. Now that we have the same base, this one's actually pretty straightforward right here. We can set them equal to each other, divide both sides by our 3, and x is equal to negative 4/3. So my fraction lovers out there, those are problems for you. All right, we are going to now move over to compound interest. A little bit different part of 7.2 here. So compound interest is interest paid on the principal, so the initial amount, on the principal deposit of an investment and any previously earned interest. So we're getting into things in Algebra 2 that actually exist in the world and that actually probably affect your life in the world right now. So the formula to calculate is actually, it's pretty complex. However, it is used often. And so a lot of different variables here. A is going to equal the amount after t years. Our P is going to equal the principal amount. So the principal or initial deposit. R is again going to be the annual rate of interest. And again, this is going to be in a decimal form. That is important. Decimal form. Our N is going to be the number of times our interest is compounded per year. All right. And finally, T is the number of years the amount is deposited. So to help you guys out, a couple of words that you might not be as familiar with. When we compound an account here, or compound the interest, if an account is compounded annually, our N is going to be 1. If it is compounded quarterly, our N is going to be 4. If it's compounded weekly, there are 52 weeks in a year. If it is compounded semi-annually, twice a year. If it is compounded monthly, there are 12 months in a year. If it is compounded daily, there are 365 days in a year, or as it seems in March or in April. All right, so looking at our last two problems here, we are going to look at a certificate of deposit pays 2.25% annual interest. And so we're going to change this rate into 0.0225. All right. It is compounded bi-weekly. So we're going to look at up here. Weekly is 52. So if it's compounded bi-weekly, 52 divided by 2 is going to be equal to 26. That's going to be our N value. All right, we are depositing $500 into this certificate of deposit. So this right here, $500, is going to be our P value. And then what will the balance be after 6 years? This is our T value right here. So now that we have everything given to us, we are going to plug and chug. Some of my favorite words right there. So after 6 years, we are looking at $500. Oh, and I probably didn't even tell you that there is a formula here. Let's back it up. That's probably the most important part right here. The formula to calculate compound interest is, and I left that blank. Let's put it over here. Let's put it nice and large. A of T equals the principal amount multiplied by 1 plus R divided by N, and all of that is to the N times T. So this is pretty important. I will just let you sink in on that for a second. Which is the reason I can now solve this down here. So I'll keep that up in the upper right-hand corner right there. And now I'm going to input all my values into here. All right. So I have 500 times 1 plus, and our R value is 0.0225 divided by 26. I'm going to close those parentheses, and there it's going to be to the N times T. So the 26 times 6 right there. And so that is what we're going to be putting into our calculator. And so if we put that into our calculator, let me show you how to do that right here. Let's look. Oh, sorry, my calculator is moving. All right. So if we put that into our calculator, we have 500. So you can actually see it this time. 1 plus, we're going to close those parentheses right there, 0.0225 divided by 26. Double close the parentheses, and we're going to all raise that to the 26 times 6. We're going to click that enter, and we have our answer, $572 after 6 years. So after 6 years, it will be $572.23. All right, our last one here. We are depositing $1,200 into an account. So right here, our $1,200 is our P value. So actually, I'm going to write these out on the side here. Let's go P equals $1,200. Compounded bi-monthly. So again, bi-monthly, well, 12 divided by 2 is equal to 6. So our right here, N is 6. Our R is actually what we're trying to find out. So we don't know our R. I'm going to leave that blank. Our time, it says we left the account alone for 10 years, is 10. And at the end of 10 years, we had $2,462.66 in the account. So at what rate did you invest your money? That means we actually already know what A of T is. And A of T is 2,462.66. So we're trying to find this R value. Well, we can still plug everything in. So we're going to go 2,462.66 is going to equal, because again, if we look at that equation up there, our A of T equals all of this. So 2,462.66 is going to equal 1,200 times 1 plus R over 6. I'm going to close that up, times, or up, I'm sorry, to the 6 times 10. It's the 60th power. Well, okay, this one's a little bit more complicated. So we definitely need to be careful of what we're doing. Our first thing we need to do is divide both sides by 1,200. And so if we come back over to our calculator, we're going to go 2,462.66 divided by 1,200. We get 2.05. I'm going to actually write that all out right there. 2.052216. And we'll go 167. At the end there, it was 6 repeating. All right, so that is going to equal 1 plus R over 6 to the 60th power. Now, you'll recall from our last unit that to get rid of an exponent, you have to take the nth root of that. So we are actually going to take the 60th root of this big old number right here. How do we do that? Well, we type out 60 first in our calculator. We then go to math, then go down to the fifth one right there, 2.0522167, and we get 1.01. So 1.0120541, and that is going to equal 1 plus R over 6. We're going to subtract 1 from both sides, which gets us to 0.01200541 equals R over 6. Multiply both sides by 6. So let's see here. Subtract 1 and then multiply both sides by 6. And that is our rate. So we have 0.0723 is equal to the rate, or in other words, that is 7.23%. There we go.